Hello medicos, welcome back to my channel. Today our topic is acid fast stain, which is also known as your Ziehl-Neelsen technique. Ziehl-Neelson Ziehl-Neelsen technique. If you have seen my previous videos, then you must already be familiar with differential staining. So basically what differential staining does is it distinguishes one type of bacteria from the other types of bacteria. So under the differential staining there comes differential staining. Under differential staining, first comes is the Gram staining, second is your acid fast stain, and third is your Albert's staining. So Gram stain, what does is it distinguishes Gram positive bacteria from the Gram negative bacteria. Your same way your acid fast bacteria, what they does is they divide acid fast bacteria from the non-acid fast bacteria. So basically the concept about both the staining is the same only. So what are the acid fast organisms? So acid fast organisms are mainly those organisms are called such as mycobacteria, which causes your TB, such as your pulmonary TB and your extrapulmonary TB. Your extrapulmonary could be your cervical TB and your spinal TB, meningeal TB, etc. So these are your the causative organisms of these bacteria are what we call is the acid fast organisms. So basically what they does is the acid fast character is shown by the or you can say the color of your acid fast organisms. They appear to be red in color, and your non-acid fast bacteria happens to be blue in color. So your acid fast bacteria are mainly your mycobacterium. They are the main causative organisms of your TB and your leprosy. And your non-acid acid fast bacteria could be your Vibrios, Streptococcus, Staphylococcus. So the word mycobacterium, if the name of the bacteria is attached with the mycobacterium, then you have to be sure that it is an acid fast organisms. And if the word mycobacterium is not there, then it means it is non-acid fast bacterium. So the procedure here is almost same only. So the first procedure is your primary stain. Your primary staining. What we do is we prepare a smear on a clean glass slide and allow it to dry and fix it by flaming. And after flaming, with what we do is we cover the smear with the carbofuscin. So here your carbofuscin is the primary stain. If you have seen my Gram staining videos, then while Gram staining, the primary stain we used was the methylene blue. But here what we use is your carbofuscin. Your carbofuscin is nothing but your basic fuscin plus phenol. Basic fuscin plus phenol. So we have done the primary staining by the addition of your carbofuscin, and after 5 to 10 minutes we heat it. We heat it and allow it to act for 5 to 10 minutes. So what we do is in acid fast staining we don't use the mordant. If you remember the word mordant, what they actually does is they help in penetrating the stain to the deeper level. But here there is no usage of mordant, because here the use of your mordant is done by your heat and your phenol. So your heat and phenol, they basically act as your mordant. So what we have, so there is no second step, there is no addition of mordant. So after heating it for 5 to 10 minutes, we wash it with water. So the second step we have to omit it, there is no usage of mordant. And the so the second is steps your decolorization. In decolorization, what we do is we do 20% sulfuric acid and pour it over the glass slide. And third, what we do is same way we take the counter staining. So the counter stain we use here is the methylene blue. In gram staining, what we did is while gram staining, the methylene blue was first used as the primary staining, but in acid fast staining, your methylene blue is used as a counter staining. So after counter staining, your methylene blue is added. So what we did is primary staining. Your carbon phosgene is there. Actually they happens to be red in color, and after decolorization we add 20% sulfuric acid, and then we add in counter staining we add the methylene blue. So why this acid fast stain happens to be red in color is there is one reason, due to the presence of your mycolic acid. Due to presence of mycolic acid in the cell walls of your acid fast organisms, they happens to resist the methylene blue, which is supposed to be crystal violet or blue in color. So your mycolic acids are actually long fatty acids. They are rich in lipids, and they are highly impermeable. So obviously if it is impermeable, your mycolic acid is impermeable, and it is easily soluble with your primary stain, which is your carbon phosgene. So if it is easily soluble in mycolic acid, so even after the decolorization process, since it is already dissolved evenly, so it is obviously impossible to decolorize. So this is the reason why after the decolorization process, decolorization step, or your decolorization step, your the color of the primary stain doesn't tend to come out, because it is already dissolved, or it is already soluble with the mycolic acid. So this is the reason behind it. Reason why the acid fast organisms are red in color is because your carbon phosgene is basically, they are soluble in phenol, and phenol happens to be more soluble in lipid substance, and your lipid substance is nothing but your mycolic acid. So what mycolic acid does is they are impermeable, which means after the during the process of decolorization, after the pouring of your sulfuric acid, what they does is they don't let the color of your carbon phosgene to fade away. So what happens is during counter staining, because it is already colored, it is not decolorized. Here no decolorization happens. So the color which was in the initial state is the same as the after the addition of your counter staining. So if no decolorization happens, then obviously the color which was first retained in your primary staining, it will retain during your final stage, which is during your counter staining. So what happens is so this is the reason behind your color, the red color of your acid fast organism. But your non-acid fast organisms happens to be blue in color, because what happens is during the decolorization process, let me remind you, there is no mycolic acid. There is no presence of mycolic acids or your lipid or fatty acids in non-acid fast bacteria. So what they does is they are easily decolorized. They are easily decolorized by your 20% sulfuric acid. So if it is decolorized, then obviously if you add a counter stain, if you add a counter stain, which is your methylene blue, then obviously it will take the color of your counter stain, which is your blue color. Your methylene blue is blue color. So this is the reason behind the blue color of your non-acid fast organisms. Let me repeat it once again. The color of your acid fast organisms are red color, and the non-acid fast organisms are blue color. The reason behind is your presence of your mycolic acids in acid fast organism. These are your lipid substances or fatty substances which are impermeable to the counter staining. So this was the topic about your acid fast staining. If you want to screenshot it, then you can surely do it. And please don't forget to like and subscribe to my channel, because if you keep subscribing, then I can come up in my later videos with better content. So thank you for watching, and don't forget to subscribe. Thank you.